Hello AP Chem students. We have our 4.A.3 homework today, and it is 13.28 and 13.30. The first one, 1328, is a kinetics problem about the thermal decomposition of phosphine. The problem tells us that it is first order and it has a half-life of 35 seconds. It wants us to calculate the rate constant. So since it's first order, we can use the equation half-life equals 0.693 over k to find the rate constant. Reorganize it algebraically and plug in 0.693 over 35 seconds, and you get 0.0198 per second, seconds to the minus 1. Part B of that question says, what is the time required for 95% of the phosphine to decompose? For that, we're going to use the integrated rate law. The form of the integrated rate law I chose to use was the natural log of the concentration of the phosphine over the original concentration of the phosphine should equal negative Kt. Any form would have worked, but I thought this one was easier because if it's 95% decomposed, then 5% is left. So the ratio of pH3 left to pH3 original should be 0.05 to 1. So that means I just take the natural log of 0.05 and divide by negative 0.0198, and I get a time of 151 seconds. Over here, 1330, we have rate constant for a second order reaction that has two nitrogen dioxides making two nitrogen monoxides plus oxygen. They tell us it's second order, and the K value is 0.54. Molarity to minus 1, seconds to minus 1. They ask us how long in seconds would it take for the concentration of NO2 to decrease from 0.62 molar to 0.28 molar. So for that one, we need, once again, the integrated rate law, which for second order is 1 over the molarity equals 1 over the molarity naught plus Kt. So we're looking to decrease to 0.28, so 1 over 0.28 equals 1 over 0.62, the original molarity, plus 0.54, the K value, times time. 1 over 0.28 is 3.57. 1 over 0.62 is 1.61 plus 0.54 t. Solving that for t, I get 3.6.